And that brings us to dividing complex numbers. So I'm not going to explain how to do this in the presentation. We're just going to talk it out. All right, I think it'll make a lot of sense based on what we just did. So we have these three examples. Let's go over to the tablet. Now, there's one thing that I really should have included in the directions, and when it comes to complex numbers, this almost always goes without saying. You have to write the answer in the form a plus b times I, okay, where a and b are real numbers, okay? So I look at 9 over 1 minus 2i, and I think, gee, how am I going to do that? So, I mean, if it was 1 minus 2i over 9, that would be really easy because I could just break that into two separate terms, and my answer would look like that, okay? Of course, that's not what we're looking at, right? But what I would really love to be able to do is take this 9 over 1 minus 2i and multiply something on the top and the bottom so that what is now in the denominator is just a real number, because then I could do exactly what I was describing right here. So, can you think of a complex number that when you multiply it by 1 minus 2i, you get a real number? Where have we seen that before? Oh, look at this. This is what we were just doing. Look at this example right here. When I multiplied 1 minus 2i times 1 plus 2i, I got a real number answer. I got 5. So I think that's the secret. If we multiply the top and the bottom of this quotient by 1 plus 2i, in the denominator, we're going to get 5. And we just did that problem, right? See last example. And don't worry, we're going to do a couple more of these where you see it again. And then upstairs, I'm just going to have 9 times 1 plus 2i. Remember, you have to write your answer in the form a plus bi. It has to be crystal clear what a and b are. So if you distribute this 9, what you end up with is 9 plus 18i over 5. And then if you break that into two fractions, it becomes 9/5 plus 18/5 I. So that's the trick for dividing complex numbers. Before we go to the next example, let me just give you a little bit of vocabulary. I'm surprised I don't have this in the presentation. A plus bi, and we had something similar a couple sections ago, I think. And a minus bi, those two numbers are called complex conjugates, or sometimes we just call them conjugates. All right, so let's look at the next example. Okay, so next we have 6 minus I over 2 plus I. So the trick we just learned in the last example is to multiply the top and the bottom by the conjugate of what's on the bottom, right? We want to change that bottom number into a real number. And we do that by using the conjugate. So if there's a plus in the middle, you change it to a minus. If there's a minus in the middle, you change it to plus. And then do the exact same thing upstairs, right? We don't want to change the value of this expression that they gave me. And as long as I multiply the top and the bottom by the same number, I'm not going to change it. Okay, so why does this conjugate thing work again? Because here I have an a plus b times a minus b, which always gives you an a squared minus b squared. Playing the role of a in this example is 2. Playing the role of b is I. Okay, and we'll come back to that in a second. What's going to happen upstairs is you're going to FOIL that. 6 minus I times 2 minus I. 6 times 2 is 12. 6 times minus I is minus 6I. Minus I times 2 is minus 2I. And then minus I times minus I is plus I squared. Okay. So let's clean up a few things here. The 12 will keep as a 12 for right now. Minus 6I minus 2I is minus 8I. What's I squared again? I squared is -1. All right, and then downstairs we have 2 squared, which is 4, minus I squared, which is -1. Be careful with that extra negative sign. All right, so 12 minus 1 is 11. Minus 8I is minus 8I. And then 4 minus -1 is 5, right? All right, so remember to write your answer in the correct form. That would be 11/5 minus 8/5 I. All right, next example. All right, I think this one is actually going to end up being a little simpler than some of those other ones. The conjugate of 3I is just -3I. All right, you change the sign in front of the I term. So we'll multiply the top and the bottom by -3I. Let's see. Downstairs, that's going to give you -9I squared. Upstairs, we're going to distribute the -3I, which is going to give me -18I minus 24I squared. -18I is just -18I. Since I squared is -1, that makes minus 24I squared plus 24. And because I squared is -1, -9I squared is just 9. Okay. All right, so 2 things about this. First of all, always put the real part first. So put 24 minus 18I instead of the other way around. And now if I split this into 2 terms, the only thing that I don't love about this answer is that it is not in simplest form, right? Not only is 18 divided by 9 2, but 24 over 9 can be simplified by taking out a factor 3. 24 divided by 3 is 8. 9 divided by 3 is 3. So the answer in standard form is 8/3 minus 2I. All right, so that brings us to powers of I. This is a really fun thing. So we know about I and I squared. I is just the square root of -1. That's kind of your base imaginary unit. And then I squared is -1. So what happens when you raise I to larger powers like 3, 4, and 5? So let's switch over to the tablet and look at that for a minute. All right, so what I'm going to do is break these down into smaller powers that I already know about. I can write I cubed as I squared times I. I squared is -1, and I we just leave as I. And so there's no reason to ever write I cubed because you can always simplify it down to -I. All right, and then I to the 4th, I'm going to break that into I squared times I squared. We know I squared is -1, so this is just -1 times -1, which is, oh my gosh, I to the 4th is just 1. All right, and then something really cool happens. You go to a larger power like I to the 5th. I'm just going to write I to the 5th as I to the 4th times I. And we just figured out that I to the 4th is 1. So you know what? I to the 5th is just the same thing as I. So moral of the story, there is never any reason really to write I to any power. You can always simplify it down to something smaller. And that brings us to something that I think I may have actually invented. I wasn't completely sure. And I guess I'm still not 100% sure, but when I searched for this picture on the internet, I couldn't find it. So that makes me think that maybe I made it up. And that's called the I wheel. So the way this works, let me see if I can, let's see, isn't there a, here we go. Okay, perfect. So it starts with I at the top. And then when you're trying to evaluate larger powers of I, you just follow the wheel counterclockwise. So starting at the top with I, you go I squared, which is, I'm sorry, there is a typo there. Oh my gosh, I'm going to have to fix that. Let me just do this for right now. Oh, I was so proud of my graphic here. I spent a little time trying to figure out how to do this. All right, is that a good negative sign? You know what? Let's pick a different color. We'll use white. It should blend in with. Okay, well, that's going to have to work. That's a negative sign. All right, let's change this back. Okay. All right, so let's try this again now. Starts at the top with I, goes down to I squared, which is -1, and then goes down to I cubed, which is -I. I got that part right. I think this was a copy and paste error. And then up here to I to the 4th, which is 1, and then it just cycles back around. This would be I to the 5th, I to the 6th, I to the 7th, I to the 8th, and so on and so on. So if you're trying to evaluate a relatively small power of I, like I to the 15th or I to the -9, you can just do that with the wheel, all right? So for I to the 15th, start at the top with 1 and then just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I to the 15th is the same thing as I to the 3rd, which is just -I. All right. Now, when it's a negative power of I, you have to be careful. Start at the top with 1 and then go clockwise. So what number comes just before 1? That would be 0. All right, so this is I to the 0, and then it would go -1, -2, -3, -4, -5, -6, -7, -8, -9. So I to the -9 also comes out to -I. All right, now the last couple of examples are a little more elaborate, so I'm going to do those on the tablet, including this one. You've seen that character come out before trying to cause trouble. He's not going to cause us any trouble. All right, but first we have the 7th power of -2i. So I'm going to use my properties of exponents to write that as -2 to the 7th times I to the 7th. Negative 2 to the 7th comes out to negative 128. And then I'll just do a quick I wheel down here. So we have I, negative 1, negative I, 1. So it goes 1, 2, 3, 4, 5, 6, 7. Let me circle these to make it. Okay. So I to the 7th is negative I. And then when you multiply negative 128 times negative I, the negatives cancel each other out and just leave you with 128I. All right, so finally we have this one, I to the power 7,843. Don't worry, I am not going to try to count all around the I wheel to do that one. The important thing about this is that it cycles in 4s, all right? So what I really need to know is how many, well, first of all, how many trips would I have to make around the I wheel? And then more importantly, how many would be left over? So that's actually a division problem. How many times does 4 go into 7,843? Well, it goes 1,960, I think 60. Okay, with a remainder of 3. So here's what I'm going to do with that. I'm going to break this into I to the 7,840 times I to the 3rd. And then 7,840 is a multiple of 4. So you can write this as I to the 4th to the power 1960 times I to the 3rd. All right, and then I to the 4th is 1. So that part is just going to fall off and is just going to leave me with I to the 3rd. All right. So people are always asking me, Mitchell, do I really have to show all of that work? And by the way, I to the 3rd, of course, is negative I. So that's the answer we're looking for here. No, you don't have to show all your work. I'll tell you the shortcut. I'm not a big fan of shortcuts, but I'll tell you. Really the only important thing about this is the remainder. All right. So whatever the remainder is, whoops, when you divide by 4, that is going to be the smallest power of I that you can use. Okay. All right. So if I were to ask you this on a test, you could just do this. You could say I to the 7,843 is just I to the 3rd, which is negative I. All right, that's going to do it for section 10.7, and that is going to do it for chapter 10. So we'll see you next time when we start chapter 11.